and look at this, armor goes up to 10. Pretty cool. Now, this is what RPG games are all about. We change things, and other things change. Everything is related by mathematical equations. And rather than just pulling numbers out of the air and plugging them in and saying, well, I'd like this to be 0.25 and this to be 2 and this to be 6, ideally, a game development team is going to test these things out. In fact, it's not uncommon for an RPG game to be prototyped as a board game first, before being made into a video game. And then these types of mathematical relationships can be fleshed out at the board game stage before the video game stage. That's a pretty common thing to do. The point is that these values are not just random. They all affect the game, and for the game to be balanced, they all have to be balanced well, which means playtesting, testing the game out, seeing how things feel, and so on. So it helps to have these values mapped out, at least have some initial values decided upon, right? And then as the game gets tested and you sort of get a feel for how things work, then you can hone in on the sweet spot for these values. And keep in mind that the values are probably going to change. Sometimes you might have these coefficients and values different depending on, say, the level of the gameplay effect, which may depend on the level of the character. It gets complicated, right? And that's why each of these can be tied to a curve table. And those curve tables can adjust these values as the gameplay effect changes. So for this, though, we're going to just choose some values. If you like, you can choose the same coefficient and pre and post multiply values for all of the secondary attributes if you want. If you don't want to sit down and start thinking about values, you can do that. But what you're going to do is you're going to add a modifier here for all of your secondary attributes, and you're going to base them on primary or other secondary attributes according to the plan laid out either by you yourself if you're designing your own attributes, or in the previous slide. So remember this slide. Now, if you want to copy these, which are pretty common, I mean, this is inspired by some of my favorite RPG games. So a lot of games use relationships similar to these, right? So that you can't really go wrong if you use these, but you could also choose to design this game the way you want to. But if you want to use these, then go ahead and take some notes or take a screenshot of this and save it, or just write it down. And as you're adding your modifiers to our infinite gameplay effect, take a look at each of these secondary attributes and their backing attribute, which is the gray little tag to the left of each attribute, and choose coefficients and pre and post multiply values for each of them. That's going to be your quest. So your quest is to add the modifiers for each of your secondary attributes. These are going to be attribute based. And this means you're going to do a little bit of planning and designing, right? So figure out the relationships that these attributes should have. And then I'd like you to change a primary attribute value using our test actor with our test actor's gameplay effect. So so that we can change a primary attribute value and see one of those derived attribute values change in response. So this is going to probably take a little bit of time. I recommend you take a piece of paper, maybe you have a notebook of notes for this course, and map out your relationships for each of these attribute values. Map out the coefficients, pre and post multiply constants, and decide how you'd like your secondary attributes to change based on the primaries. So a little bit of game design going on here. So pause the video and conquer this quest now. Kind of like to. So here's a page from some notes that I've jotted down during the design stages for this project. And as you can see, notice that it's filled with equations, just ballpark figures that I felt might be appropriate in gameplay. And these are, of course, things that can be adjusted as we continue to test out gameplay in the project. Now, this is very commonly what my notes look like. I very much like to write notes by hand. I also use tools on the computer, but when I'm brainstorming, I like to sit down and kind of just that made it into the final project and things that didn't. You'll see that I have speculation, possibilities, things that may or may not I'd like to keep and implement. So I have my coefficient, pre and post multiply values, and this is all for my armor attribute, and it's backed by resilience, and I think it's looking good. So I'm going to go ahead and minimize that index in my modifiers array and add the next one. And the next one is going to be for armor penetration. So I'm going to go ahead and add that one. Now, each of these is backed by a single attribute, but we've seen that we can have multiple modifiers for any given attribute that we'd like to change. So keep that in mind. One attribute can be backed by multiple other attributes if we want. Now, recall that our first modifier was set to override for the modifier op. These are all going to need to be override. So I'm going to set this next one for armor penetration to override. Modifier magnitude will be set to attribute based. And the backing attribute for this one, I'm going to expand that, is also resilience. Now, the values I've chosen for this one are a pre-multiply additive value of 1, a coefficient of 0.15, and a post multiply additive value of 3. There's our block chance, right? Be a coefficient. Let's add our next modifier, and this will be for critical hit chance. So we'll choose critical hit chance. It's going to be override. And let me just make sure, yes, my block chance was set to override. It's very important to keep double checking these things, as one incorrect setting could make things not work right. Attribute based, attribute source, a coefficient. And that's it. That's critical hit chance. Now, for the next one, and this will be critical hit resistance. It's okay, we'll get that next. Critical hit resistance to a post multiply additive value of 10. That's a hit damage game, right? Now, we'll set this to attribute based. The equation looks our 9th element, our max mana. Okay, perfect. So let's go ahead and compile and save. We have quite a few changes, so I'm going to hit save all, so we save this test attribute. And now we can simply test it out. I can show debug, and here's the thing. Once we start having lots and lots of attributes, well, our screen is kind of too crowded to show them all. We have too many secondary attributes all being affected, critical hit resistance, critical mechanics. It's going to be hard to show them all in a debug setting, and that for us is a nice way to visualize our attributes, gain some attribute points that she can spend on various attributes, and then customize the builder attributes. And those relationships are mapped other factors, not just other attributes, but other variables associated with the character. we'll capture from the target. In intelligence, I'd like to have a base value of 50, and we'll have a coefficient of 2. So max mana is 50 plus 2 times intelligence. So if intelligence is 15, then in other words, perfect. Save also, we save this debug attributes. Well, our screen is being affected. C5, we see our max. We're quickly seeing the limitations of show debugability system or have these types of mechanics. Like most RPG games, we're going to want a menu that shows us that's going to be click to show that attribute, way to visualize that will be responsive, and also aura levels up attributes. These are those attributes that are derived from other attributes, and based on our attribute. Sometimes you might want an arbitrary Welcome back. Now that we know how to have attributes backed by other attributes, we've seen the limitations of the modifiers and the parameters that we can set for those modifiers. Now, they are quite versatile, but if we want an arbitrarily complex calculation, we have to use other means. This is where custom calculations come in. Let's say we have a modifier, and the attribute that we'd like to affect is max health, and we'd like to use override. Let's say we'd like this to be in our infinite gameplay effect so that our max health is dependent on other attributes. Now, let's say that we'd like our max health to be equal to some base value, say 80, plus a multiplier multiplied by our vigor attribute. We know how to do this. That's no problem. But then let's say that we have some other value, maybe the player's level, and we'd like to add some multiple of that to the max health. So that way, if the player gains a level and their level goes up, their max health will go up by 10. Now, if level were an attribute and the attribute set, this would be no problem. But that's not necessarily how we want to implement the level. So vigor, that's an attribute in the attribute set. We know how to use those in our attribute-based modifiers. But what do we do with level? What if that level variable exists somewhere else, like in the player state? How do we make an attribute that's derived from both vigor and level? Well, we could use a custom calculation, or in other words, a modifier magnitude calculation. We refer to these as MMCs. This is a class that we can create that determines the calculation that should be used for the modifier. So we wrap up this calculation into an MMC and set that on the modifier. And then we can have any type of calculation that we wish in the MMC itself. So in this project, I'd like to implement things like this. I'd like my level to not be an attribute, but rather be a variable on the player state class. Now, level could be an attribute. You could make it one of the attributes in your attribute set, and that would be perfectly fine. But I feel like the level is not really appropriate to be an attribute. And not just because level is not necessarily a float, but is probably going to be an integer. That's not a problem. But it's more because attributes are numerical values that have these complex interrelationships with other attributes and other phenomena in the gas system. Whereas level is more like a counter for your progress. Yes, we will have things trigger in response to the level changing. Of course we will. But not in the same ways that we'll have things trigger in response to attributes changing. And for those reasons, I'm going to have the level on the player state. Besides, it's an opportunity to show another way of doing things. And we're going to do it this way. Now, our MMC is going to be able to access some information within it, particularly related to the source and the target of our gameplay effect. And I'd like my MMC classes to be general and not closely dependent on very specific classes like our player state or our character class or things like that. Rather, I'd like it to be dependent on abstractions like interfaces. So when we add the MMC to our modifier, it's going to be dependent on an interface instead of specifically the Aura character class or the Aura player state, for example. I'd like a combat interface that can be shared between all classes that participate in combat. And then our combat interface can have some kind of function to retrieve the player level. And that way, our MMC will not be dependent on specific classes, but rather this abstract generalization, the combat interface. And then anything that implements the combat interface can implement this getter function for the player level. And then it doesn't necessarily have to be a variable that exists on the player state. It might be on the individual character class for enemies, for example. And all they need to do is implement the interface. So the implementation details are specific to individual cases, but the MMC can just use this generalization. And this is more flexible code, and it's considered more along the lines of best practice and clean code. So that's how we'll do it. So that means we have a few next steps to worry about. First, we need to add a level variable to our player state. That's where I'd like to keep this level amount. And then we need to create an interface. I'm going to call it combat interface so it can be shared among all classes that participate in combat in our game project. In this combat interface, we'll have a function to retrieve the level associated with whatever implements this interface. And then we can create our MMCs. I'd like to make an MMC for both max health and max mana. That way, they can be dependent not only on their backing attributes, but on other variables such as the level. So we're going to make these max health and max mana attributes dependent on level and their original backing attributes. For max health, that's vigor, and for max mana, that's intelligence. So in the videos to come, we're going to implement these steps before we go on to make our attribute menu. Great job. I'll see you soon. Welcome. In this video, we're going to add a player level to our player state class, and then we'll create a combat interface and implement that in our project. So first, let's go to our public folder into player and open up Aura player state. And in Aura player state, we can have a variable for the level, and I'd like this to be a private variable. This will be private here in the player state, and it's going to be an int32. So level is just going to be an integer, and it'll have a default value of 1. And I'm going to give it a U property with visible anywhere, just in case we want to see it in our blueprint. Now, level is going to be replicated. I'd like it to have its own rep notify as well, so that later on when we're going to be showing this in the HUD, we're going to want to make a broadcast whenever this replicates. Now, to replicate anything, we need to override get lifetime replicated props, don't we? So we're going to do that here in the public section. We're going to say virtual void get lifetime replicated props. Props all. For level, and we can add a rep notify void on rep in the private section all, and then we can add a rep notify right here, rep underscore level. That way we can, otherwise it's cated. And we're okay. Equals on rep level. Okay, use that soon enough, get lifetime to the most big props. Now for this, for / Unreal Network. Now this is followed by level is replicated variable will reside. For enemy characters, for enemy characters, I'd like the level to be on the enemy character itself, on aura enemy. So for that case, let's go back to the self on aura enemy. So for that case, let's go back to the character folder and open aura enemy. And we'll give aura enemy a private section with its own level variable. So this will be an int32, we'll call it level, we'll set it to a default value of 1, and we'll give it a uProperty. And for this, I'd like it to be edit anywhere, blueprint read only, and I'll give it a category of character class defaults. Now the reason I'm not going to make this replicated for the enemy is because we're only going to be concerned with checking the level on the server for AI calculations will has a level variable and or that can retrieve the level, and we can implement that on our character class, and then any character can call that function to retrieve the level, and it's up to the individual character to determine how to get that, whether we get it from the player state or just return that value from the character itself in the case of the enemy. So we're going to go ahead and launch the editor. Of course, that I'm going to move it actually. So level is now protected instead of totally get around that. I'm the editor. Okay, so what we need is an interface. So I'm going to go into our C++ classes, Aura, public, and we have an interaction folder for our enemy interface. We're now going to have a combat interface that will be shared between both enemies and the player-controlled character. Enemy interface is unique to enemies only, so this one will be shared. We're going to have this class in the same folder, interaction, and it'll be an Unreal interface. Let's click next, and here in interaction, we'll create our combat interface. So we'll go ahead and close the editor. Next, same folder. So this one will be shared. We're going to have this class in the same folder, interaction, and it'll be an Unreal interface. Let's click next, and here in interaction, we'll create our combat interface. So we'll go ahead and close the editor and let Writer populate our folders with our new interface. And we should see it here in interaction. Here it is, combat interface. And I just want to implement one function here in combat interface, right here in the public section. So it's going to be virtual, and it's going to return an int32. And we're going to call this get level. I don't want it to be required that we implement this. If we don't implement it, I want to simply return 0. So I'm going to generate a definition. This will be a default definition that returns 0 here. And then we can implement this in, say, the base character class, who doesn't need to implement it, but because the base character class has classes. So I'm going to generate and implement it. I want to simply the section, one action. Here it is, combat interface. And I just want to implement one function here in combat interface, right here in the public section. So it's going to be virtual, and it's going to return an int32. And we're going to call this get level. I don't want it to be required. That we implement this. If we don't implement it, I want to simply return 0. So I'm going to generate a definition. This will be a default definition that returns 0 here. And then we can implement this in section that returns 0 here. And then we can implement this in, say, the base character class, who doesn't need to implement it, but because the base character class has combat interface, then we don't have to implement it individually in each subclass of the base character. So let's go to Aura character base in the character folder, and let's implement this interface. So not only iAbility system interface, we're also going to inherit from iCombat interface. And Writer should give me the opportunity to include the header file. And there we go. So now our base character class, Aura character base, is also a combat interface. And then we can implement get level in both Aura character and Aura enemy. We'll first do it in Aura enemy, and this is going to be public. And right here, I'm going to make a multi-line comment that says combat interface. And beneath it, we'll close it out with end combat interface, and we'll implement that function virtual. Right? So let's go ahead and generate this definition and return level. We don't need to call super. We're going to return the level variable. And for Aura, we're going to return definition and return the level variable. So let's go ahead and generate this definition and return level. We don't need to call super. We're going to return the level variable. And for Aura character, it's going to be different, isn't it? Because our level will be on the player state. So let's go to Aura character and we'll override that function here. It's in the public section. So we're going to have a multi-line comment that says combat interface. And we'll have another multi-line comment beneath it. That says end combat interface, and we'll override the function virtual int32 get level override. Let's go ahead and generate a function definition, and this one will return something else, won't it? We have to get our player state. We're doing that right here in init ability actor info, so we can copy that line right here. We can simply copy that. We can even do the check for Aura player state here, and we can simply get the level from Aura player state. Now, in Aura player state, level is private, so we should make a public getter to retrieve that level variable. So right here, we'll do it. We're going to say int32, not 43, but 32, get level. It'll be const, and it'll return level. Now, in this case, we're hiding a function. There's a function called getLevel on the actor class. Now, that tells me it's going to be a problem for all the other classes. So for that reason, I'd like to change the function name to getPlayerLevel on all fronts. So I'm going to change it here. I'm going to change it in the interface itself. Let's go to combat interface. Let's just go ahead and change this to getPlayerLevel. And that means I need to change it here in combat interface.cpp. And that means go to combat interface here. I'm going to change it in the interface itself. Let's go to combat interface. Let's just go ahead and change this to get player level. And that means I need to change it here in combat interface.cpp. We also have to change it in aura enemy.h and cpp. So let's change it to get player level there. CPP, we'll change it to get player level there. And in aura character, we'll change it to get player level here. here and get player level here. And we can call that getter. And before we do, let's just go back to Aura player state for a second. And I was going to say that this is a nice, simple little function. We can mark it with force inline. Now, you'll notice that I'm not using force inline very much in this course, and I've used it. Now, you'll notice that I'm not using force inline version. We can mark it with force inline. Now, you'll notice that I'm not using force inline very much in this course, and I've used it quite a bit in other courses with getters. This is one of those micro optimizations that you tend to kind of see overused a lot, and it doesn't make a huge difference at runtime. It is a small optimization. It basically means that whenever we call get player level, the preprocessor is going to replace that function call when processing before the compilation step with the function body, in this case, the level variable itself. So ultimately, the compiler has to say over whether it ends up doing that or not. For small things like this, it's usually okay. You're not really going to cause any harm by overusing it, but that's why I don't use it very much. I'm going to go ahead and use it here, though. And since we have a getter, we can go back to Aura character, and we can get that level. So we can return, with lowercase, of course, return Aura player state, get player level, like so. And this could be a const local variable here. So now Aura character implements get player level. Aura enemy implements get player level. It just returns level. This could really be on one line. You know, as a matter of style, you could change it if you want it all in one line like that. But now that our character and enemy can have get player level called, and in the case of the enemy, they'll return the level variable that's on the enemy class. In the case of Aura character, it'll return the player level that's on the player state class. That's all great. Now we have an interface we can use to easily get the player level if we want to. in a custom calculation class. And the custom calculation class is what we will make next. So let's go ahead and make sure our code compiles here. And suddenly my player controller doesn't like TObject pointer being used for last actor and this actor. It was legal before, but now it's telling me to stop using TObject pointer for the enemy interface. So that means we're going to need to use raw pointers for the enemy interface. We'll go ahead and leave that as a raw pointer instead. Let's go ahead and compile again. And there we go. We have a successful compile. Great. So great job, and I'll see you in the next video. Pilot pointers for the interface. Welcome back. In this video, I'd like to make a custom calculation class so that we can have our max health and max mana not only dependent on other attributes, but other variables that are not attributes as well. So that's going to involve making some changes, not only to our gameplay effect, if we go into default attributes here, and open secondary attributes, specifically Aura secondary attributes, we have all of these modifiers and we have max health and max mana at the bottom. These have their modifier magnitude calculation type set to attribute based, but I'd like to use custom calculation class. So not only are we going to want to change this gameplay effect, but we're also going to want to create that custom calculation class. And that's what we're going to do first. So to do that, we're going to go into our C++ classes folder, into Aura public ability system, as this is related to the ability system. We're going to right click and make a new C++ class, but we have to choose all classes. And we can find the class we're interested in if we type in mod mag. And we see that we have a gameplay mod magnitude calculation. This and we click and make a new C system. As this is related to the choose all classes. See that we have a gameplay mod magnitude calculation. This is that modifier magnitude calculation, or MMC class that we're interested in. So we're going to choose that class. And here in ability system, we're going to put this in a subfolder called MMC for modifier magnitude calculation. If you don't like the acronym there, we can call it mod mag calc if you want to do that, MMC. Either way, we'll go ahead and leave it at mod mag calc. And this is going to be the MMC for max health. So I'm just going to call it MMC underscore max health. So let's go ahead and create this class. I'm going to go ahead and close the editor, and I think I'll close all of my tabs up here. So that way I'll have a clean slate, and we can open our public folder, open ability system. Here's our new mod mag calc folder, and here's my new MMC called U MMC max health. Now there's the U because this is based on the U gameplay mod magnitude calculation class. So max health is to be determined by the calculation we create here. Now, I'm going to go ahead and Alt-O or Control-K-O to open max health or mmc maxhealth.cpp. So I have both files open here. And it's completely blank and empty. And if this is your first time creating one of these, you have no idea what you're supposed to do, right? And that's why we're going to do this together for the first time. Now, my ModMag calc needs its own constructor, and I'm going to make a public section and put my constructor in it. So first things first, we'll get our constructor declared like so, and we'll go ahead and generate the definition for the constructor. constructor. Okay, that's step one. So far, so good. Now, how do we actually calculate our custom calculation? Where do we put it? Returns float, should produce this float value we're going to determine here in this function, and it's called, now I just let autocomplete fill it out for me here in Writer, but it's calculate base magnitude implementation. And it takes an F gameplay effect spec. Look at that. We get the gameplay effect spec, and that's going to be the effect spec of whatever gameplay effect that has a modifier using this custom calculation. So we have access, and that's attributes. They have access to all the stuff in the effect spec, user attribute variable, and the definition. I'm going to go ahead and let autocompute capture. And okay, so we've declared a new function. We've made a new variable. Let's create the definition for this function, and we don't want to return the super. We want to return the value that we calculate. Now, if we're going to have this vigor def, right now it's just an empty variable, we have to make sure we capture the vigor attribute. And we do that here in the constructor. We say vigor def dot attribute to capture. We specify the attribute to capture. And we can access an attribute from Aura attribute set with the static function uAura attribute set, : get vigor attribute. Why can we do that? Because the we vigor def attribute, an empty variable. Now, if we're going to have, we want to return the value that we, it's just an empty variable. In the constructor, we say vigor def dot attribute to capture. We specify the attribute to capture. And we can access an attribute from Aura attribute set with the static function uAura attribute set, get vigor attribute. Why can we do that? Because the attribute accessors macro, that boilerplate macro, in case you forgot, I'm just going to show you real quick here in Ability System. Here's Aura Attribute Set. This one right here, attribute accessors. We know that attribute accessors consists of these macros, and one of them is the property getter. Okay, this macro results in the creation of get vigor attribute because we called it with the vigor attribute. This get vigor attribute is a static function. That kind of means a lot, right? It means we don't have to have a pointer to the object, the Aura attribute set object. We can just call the static function to get the attribute itself. That's why we can call it like that here. Now, Aura attribute set is now included here. Make sure if you don't have fancy tools like Writer doing these includes for you, that you make sure to include that, of course. And if we're capturing vigor, we have to define whether we're capturing vigor from the target or the source. Now, in our case for this, we're applying the gameplay effect from the Aura character to the Aura character, so they're both the same, but we're going to specify here. So we're going to say vigor def dot attribute source. We want to define the attribute source, and we use an enum for this, gameplay effect attribute capture source, and our options are source or target. These are settings that we see in the gameplay effect as well. Here in C++, they're enums. So we're going to choose target, and we also should decide vigor def dot. We should decide whether we target. These are settings that we see in the gameplay effect as well here in C++. Plus their enums. So we're going to choose target, and we also should decide vigordef dot. We should decide whether or not to snapshot. Now, I mentioned that we would talk about snapshotting later. We're going to set this to false. And snapshotting has to do with timing. When do we want to capture the attribute? When the gameplay effect spec is created, or when the gameplay effect spec is applied? Well, in our case, those two things happen one after the other. We create the gameplay effect spec and we apply it immediately within the same function call, so it doesn't really matter. But later we're going to be creating gameplay effect specs and then not necessarily applying them immediately. For example, we might create an effect spec and set it on a fireball that flies through the air, and then eventually that fireball may or may not hit something, and then apply that effect spec. And so the question is, if we're capturing attributes in that gameplay effect, do we want to capture them when that gameplay effect spec was first created at that point in time, or do we want to capture them when the effect is applied at that point in time? Snapshotting is capturing the attribute right away, as soon as the effect spec is created. Not snapshotting is getting the true value at the time of application of the effect. In our case, it doesn't matter. We're going to use false. Now, after we've set these properties on vigordef, then our modifier magnitude calculation needs one of its variables, which is an array of attributes to capture. We need to add this vigordef to it, and that array is called relevant attributes to capture. It's a T array of type f gameplay effect attribute capture definition. That's the type that our vigordef has. So we're going to call add, and we're going to add vigordef. So we've created this vigordef, which is an f gameplay effect attribute capture definition. We've configured that capture definition definition and added it to our MMC's array of capture definitions called relevant attributes to capture. This way, when the modifier is executed, when the effect is applied, then we will be sure to have vigor captured from the target at the time of application. And we can access that here in our calculate base magnitude implementation function. Now we have things that we can do here in this function. We can get any gameplay tags that the source or the target have, and we're not going to use gameplay tags on the source and target for this MMC, but just in case you may want to do so in the future, we're going to learn how to do it anyway. So let's make a comment that says gather tags from source and target. They can affect things if you want them to. So first, we make an F gameplay tag container, and that's going to be, it has to be a pointer, and we call it source tag. So I made it a const pointer, and we can get it from the spec because the gameplay effect spec has the captured tags from the source and the target. We access them with the spec dot captured source tags dot get aggregated tags, and any tags that source has, we now have in this gameplay tag container. We can do the same thing for target tags. We can say f gameplay tag container. It's got to be a pointer, and we're going to call this target tags, and we can get it from spec dot captured, in this case captured target tags dot get aggregated tags. That's how you get the tags. Now, in order to capture an attribute and get that attribute's magnitude, its value, we have to create something called an f aggregator evaluate parameters. So we have an f aggregator evaluate parameters. We're going to call this evaluation parameters. And when we create one of these, the evaluation parameters has its own source tags and target tags. So we pass those on. So we get our source tags and pass those in, and we take our evaluation parameters dot target tags, and we also set that using our target tags. So these are parameters that we have to pass in to a specific function in order to capture the attribute we're interested in. In our case, it's vigor. And we get that captured value with the function get captured attribute magnitude. And this takes the f gameplay effect attribute capture definition. We have that. That's the vigor def. So we get that. We also have to pass in the gameplay effect spec. Good thing we have that, right? So we pass that in. And then it requires those aggregator evaluate parameters. So that's why we have to pass in our evaluation parameters. And then finally, how are we going to get that actual value for vigor? Well, we pass in a float by reference, and it's non-const reference. This function is going to set that float equal to the magnitude or value of vigor at the time it was captured. So what we do is we make a local float, non-const, called vigor. We initialize to 0 because we're good and never have uninitialized variables. And then we pass in vigor. And after calling this function, vigor will now have the value of the vigor attribute on the target. We can always run in debug mode and see if that is the case. But for now, we're going to assume that it is. And we're going to take that vigor. And usually, sometimes we clamp it so we can take vigor and set it equal to fmath. And a common trick to make sure that this is never a negative value is we use max. So we can use max specifying float, which takes 2 values and returns the maximum. And we would pass in vigor and 0. And that way, if vigor is less than 0, then we set it to 0. So that's a common thing that you'll see happen. So now we have the value of vigor. That's step 1. But as I mentioned, we want max health to be dependent not only on vigor, but also on the player's level. And that's the whole reason we created the combat interface, because we can always get the source object of this gameplay effect. We can get that from the spec. We can say spec dot get context dot get source object. And the source object, as we can see, is a U object. And as long as this gameplay effect has a source object, we can cast it to that interface. So in our case, the source object is going to be, well, aura, right? Aura character. So we're going to cast to our interface. And we're casting to iCombat interface. And of course, the header was auto included. So there it is there. And I'm going to create an iCombat interface local variable called interface. Actually, we'll call it combat interface to be exact. And then we can have access to the level by saying const int32 player level equals, and we can take our combat interface and call get player level. So just like that. So now that we have our level and our vigor, we decide what this custom calculation returns. It returns a float here, which means we can have a return statement, and we can calculate the value returned for this modifier calculation however we want. So the design that I'd like is to have a base value of 80.f plus, and I'd like to have my vigor multiplied by 2.5. So I'm going to say 2.5f times vigor. And I'd also like to add 10 times, so 10.f times player level. So now our calculation can be whatever we want it to be. We could make this as complicated as we want. We have full freedom here in C++. What I want to do is just have a base value of 80, and for every vigor point that we have, we get 2.5, and for every player level we have, we get 10. So as the player levels up, maybe they gain some points that they can spend on their attributes, and they up their vigor. If they spend 1 point and up the vigor by 1, then their max health will go up by 2.5. If the player levels up and their level goes up from 1 to 2, then they get 10 more added to their max health. So that's how I'd like this to behave. And now we have a custom calculation that we can use in a modifier for max health. So the next thing to do is to test this out. So I'm going to run in debug mode. So the next thing to this works. GE Aura secondary. Okay, so we're back attributes open. And let's go through the settings. Its attribute is max health, modifier op is override, but magnitude calculation type is attribute based. That's not what we want anymore. We now want to choose custom calculation class. Now our options are different. As soon as we expand custom magnitude, we can now choose a calculation class. And if we expand the dropdown, the only option we have aside from none is our MMC called max health. MMC max and pre and arbitrary efficient, whatever you multiply, it really is target tags. Well, tags. Required tags are tags that have this modifier applied. Ignore tag says none of these tags may be present. So there's the ability to say if the target has a specific tag, then we cannot apply this modifier. So there's just yet even more options for you. But now that we're using the custom calculation class, we should see something different for our max health. Let's just look at our calculation. Max health should be 80 plus 2.5 times vigor plus 10 times player level. Let's see if the math works out there. I'm going to go ahead and press play. And right away, since we're running in debug mode, I got a problem here. Combat interface is null. And that's because we called get source object. And I'm assuming our source object is null. Let's make sure. Let's hover over spec, or either that or coming down here and expanding the dropdown for spec. And our source object will be buried deep in effect context. Let's expand its data, and here's source object. And we see that it's null pointer, which makes sense because we're not setting a source object. Where do we set the source object? This is something you should know. Remember, it goes back to where we're applying the effect, and we're doing that in the character class. If we open the private folder, open character, and go to aura character.cpp, scroll down. Nope, it's actually aura character base. Yes, apply effect to self. Here we're applying the effect, and here's where we have the opportunity to set a source object, right? So let's make sure we're setting a source object. Let's go ahead and hit stop. And how do we set a source object? Can you remember? If you can't remember, at least think back to where we did this before. Actor, you you'd be right. We added it to the handle. We have an f game. We need right. We have to add the object. So let's go back to or and go back to use object. Let's go ahead and hit stop. And how do we set a source object? Can you remember? If you can't remember, at least think back to where we did this before, right? Where did we set a source object before? If you thought about Aura Effect Actor, you'd be right. We can go back to Apply Effect to Target, where we added a source object here. We added it to the effect context handle. So we have our F gameplay effect context handle, which has add source object. So let's go back to our character base. We have an F gameplay effect context handle. Now, here's the thing is we made it const, but now we need to change something on it. So we're not going to make it const anymore. We're going to take context handle and use add source object to source. So add actor, right? Remember, how do we setting a source object? Let's add a source. Here, QPP, scroll down. Nope, it's actually Aura character base. Yes, apply effect to self. Here we're applying the effect, and here's where we have the opportunity to set. So go ahead and hit. Remember, if you can't remember, did we set right? We can go back to apply effect to target, where we added a source object here. We added it to the effect context handle. So we have our F gameplay effect context handle, which has add source object. So let's go back to our character base. We have an F gameplay effect context handle. Now, here's the thing is we made it const, but now we need to change something on it. So we're not going to make it const anymore. We're going to take context handle and use add source object. And for the source object, this is very important. We have to add the character, right? We have to add this. Why? Because the object itself, which will be aura in this case, or in the case of the enemy, the source object is the class that has the implemented interface function get player level from our combat interface. So that's why we need to use the character itself. So now when we apply the effect to self, it'll have a valid source object. So this was a pretty good learning exercise, running in debug mode and capturing that problem, right? If we were not running in debug mode, we would simply have crashed the engine, and we might not be really all that aware of what caused the crash. But since we did it this way here in MMC Max Health, we were able to see that our cast to combat interface failed, and we could dig deep into our gameplay effects spec to see that that source object was indeed null. So let's run in debug mode yet again and try this again. And keeping in mind that calculation, 80 plus 2.5 vigor plus 10 player level, let's make sure that that is checking out when we look at the value. Go back into GE or a secondary. The reason is because we kind of crashed. I mean, we hit a breakpoint in debug mode and then closed the engine with that stop button. So that means that our max health modifier is back to being attribute based. So we need to set its magnitude calculation type to custom calculation class and expand that dropdown and set the class to MMC max health. And that way we can use this. And to avoid losing that progress, we can just save all and let's press play. All right, so so far we're good. Let's see if we can see our max health value. We may not be able to because we just have too many attributes. So unfortunately, no, wait, I see it right here. Here it is. I don't know if you can see it on your screen. It might depend, but I see 112.5, 112.50. Let's see if 112.50 makes sense. We have 8.50. Let's see if 112.50 makes sense. We have 80 plus 2.5 times vigor. And what was our vigor? I can't see it in debug, but I can know by checking on the vigor modifier here. And this will be a lot easier once we make our attribute menu where we can see all these. But let's find it. It's actually one of our primary attributes, so we'll open that. And here are our 4 modifiers. Vigor starts off at 9. Okay, so vigor starts at 9. So we have 80 plus 2.5 times 9. 80 plus 2.5 times 9 plus 10 times player level. Now our player level should just be 1. We set a default value of 1. Now I'm going to just pop up a calculator and see if we can calculate this. So I'm going to add 5, 32.5, 12.5 we had, I believe it was. Let's just double check. 112.5, yes, 112.5. So that's 112.5. Is that what we had? I believe it was. Let's just double check. 112.5, yes. It's 112.5. let's just double 5. Is that what we had? And that gives us 1. Let's just double check. It checks out this breakpoint here, and we apply this effect right away, and we can see all sorts of information because we and simply start the game. That's going to trigger the breakpoint immediately because we apply this effect right away, and we can see all sorts of information. Right? We see that player level is 1 as we expected. We see that vigor is 9 as, again, we expected that. And of course, we can hover over properties here in debug mode and expand drop-downs to get all the information at this point in time where the breakpoint was triggered, right on this line. So as you can see, the mod magnitude calculation, MMC, is a very powerful way to have a custom calculation type in one of our modifiers. And it does have its limitations. It can only modify a single attribute. So if we want to use more than one calculation, we'd have to add another modifier and modify the same attribute again. Level. This is both vigor and this effect was applied in the player state, but instead on about that. That enemy well coded. So now that we know how to do this for max health, we can do it for max mana. And this self, its own intelligence. Click. Now I'm going to fix mine with 5 so they CPP. I'm going to take next to it. If this is what you did, you could do. Is to look at max health and see how we did it here. Because really, that's what programming, you're always going to be. So first we have a constructor here in max 4. It'll help. Help you out. So first we have a public section that we want, which did on in. Want to over. Let's want to return gameplay effect did on in capture definition. I'm going to go ahead and copy that whole thing. Don't want to capture vigor. And now set the attribute to captures, and then we added our capture definition. Let's copy it and paste it. And for our attribute set, I'm just going to use Control H. Copy it and paste it to include place all that I want to. You can just do int. It's fine. I'll fix that. It's intelligence. Attribute was pretty smooth. So same thing, just int instead of vigor. Now let's see what we did. Target tags. We made a value. Evaluation parameters, and then we called get captured attribute magnitude. So and we'll just change things. The first like half of the function is I'm just going to call it int, and we're going to pass in int instead of vigor. We're setting vigor equal to the result of a max between int and 0. Did I say vigor? I meant int. Sorry, that was confusing. Let me say it again. We're setting our local int variable equal to the result of max, and the result of is negative up. Soon include the header successfully, then apply combat interface. Check the pointer. I'd rather it just crash instead, or running in debug. We're getting the player level from it, and now we choose a calculation here. Now for it, to add substance and maybe something like that. So pretty simple calculation. You know, there's potential here to be much more complicated if we needed to, but first we now have it. And with that, we can open up our secondary attributes effect. Its attribute we can choose. Now we have MMC max mana. We're going to choose that. And that's it. We can go and press play, and I don't know if we can see max mana in them that we can't really. So what I can see is simply, at least I don't see it on my screen, and run the game. So what I could do is mana, at least I don't see it on my screen. So what I could do is simply place a breakpoint there. So see our max mana, at least I don't see it applied to them that we can't really see our max mana, at least I don't see it on my screen. So what I could do is simply place a breakpoint there and run the game. And then that's correct. Our level is 1. So yeah, this function will return this value. And once we add some more UI elements, I'm going to go ahead and resume, then we'll be able to displace. And so that'll be some of the next things we do. And if we go up to low values, 10 value of max health, but the value of max health depends on the value of other attributes. So how are we going to get the max health to them equal to low values, attribute set up? I don't want to do that. And I don't want to have to hard code those values, right? So I'm going to save all. If we go up to our attribute set up to the constructor, we see that we're setting these both to low values, 10 each. I don't want to do that. Our max health depends on the value of other attributes. So how are we going to get the health and mana initialized to the correct value, the exact value they need to be to fill up those globes? We'll figure out how to do that next. I'll see. Welcome back. So we're initializing health and mana with hard-coded values, and that's definitely not something that we like to do, is it? So we're not going to do it that way. We're not going to call init health and init mana here in the constructor anymore. I'm removing those. Now, what do we want to initialize health and mana to? Well, our max health and max mana are dependent on other attributes. Max health is dependent on vigor. It's also dependent on player level. Max mana is dependent on intelligence and player level. So it's kind of hard to tell what that's going to be if we want to hard code it in, but we don't want to hard code it in. We want to set health and mana to the max values, and we have to do that after max health and max mana have been set. So timing is important here. And again, what's our preferred, or at least my preferred way to set attribute values? That's, well, by gameplay effects. So I would like to have gameplay effects that initialize health and mana and initialize them to the values of max health and max mana. That's what I'd like them to be set to. And this doesn't need to be an infinite gameplay effect. It could be an instant one that just sets health and mana, just initializes them. So that's what I'd like. And this is going to be your quest. Do this by creating a gameplay effect to do so. Value of max health, and set your mana test. This, right? And at least set for the first time. You have all the skills that are vital. Okay, so I think that should be for the gameplay effects that initialize our attributes. And that's going to be on our Aura character base class. Right here we have default primary attributes, default secondary attributes, and I'd like to set our default vital attributes. So we're going to have, we're going to have a gameplay effect class for that, and this will be default vital attributes. And how are we going to apply it? Well, we have our nice apply effect to self. We can call that if I control KO over into the CPP file. I see that first we're applying the default primary attributes, then the default secondary, and after that, we can do the vital because our secondary attributes have to be set before the vital because the secondary attributes include max health and max mana. So after this function call, the secondary attributes will be initialized, and now we can initialize vital equal to the values of those secondary attributes. So we're going to call apply effect to self, passing in 1 attributes gameplay effect. So let's go ahead and run. We should see our health and mana tweak default attribute effect this to be an int to set the value of health. We're going to initialize it. So the attribute is going to be health. The modifier op will be override. The magnitude is going to be attribute based because we want to set it equal to the attribute of our max health. So the attribute to capture will be max health, the attribute source will be target, and that's all we need for health. We're going to do the same thing for mana. So I'm going to collapse that index and add another modifier. This modifier's attribute will be mana. The modifier op will be override. Modifier magnitude calculation type is going to be attribute based. We'll expand this, and our backing attribute is going to be max mana. It's going to be from the target, and that's it. Now, as soon as we start the game, we should have this gameplay effect applied as long as we set it. On aura. So we need to go back to blueprints, character, aura. Aura, BP aura character, via asserts now it's, and look at mana, the health or mana anymore. So show debug is a little bit less useful these days, but we're good. I trust it. I think that my health and my mana are correct. We'll be doing those things next. But for now, great job. And this is a good milestone. The different modifiers, and there are different types of magnitude calculation types. We learned about scalable float and attribute based. We know about custom calculation class. We don't know about that fourth one there, set by caller. So that's the one that we still need to learn. We'll get to that in this course. And you're a lot more powerful just knowing those three. So it's just a testament to how useful and powerful gas is. So congratulations on all we've learned so far, and it only gets better from here.